given any 2 points in the Cartesian coordinate system, we'd like to develop a way to find the distance between those 2 points. Okay? So today we'll try to figure out a way to do that. We're going to derive what's known as the distance formula. So let's first try this by plotting 2 arbitrary points. I want to plot a point, we'll call it x1, y1. So maybe we'll plot this point right here. There's the point x1, comma, y1. And I'll call that point P1. Okay, so there's point P1. And I want to plot another point, maybe this one right here. We'll call that P2, and that's going to have coordinates x2, y2. And what we want to figure out is what is this distance right there. Okay? What is the distance between those 2 points? Well, it might look a little complicated, but it's really not. If you know the Pythagorean theorem, we can certainly use the Pythagorean theorem to help us find the distance. Well, so what I'm going to do is I'm going to just draw some dotted lines straight down from this point, straight across from this point, and notice I'm forming a right triangle. Now remember, the Pythagorean theorem says that a squared plus b squared is equal to c squared. So I'll try to use the Pythagorean theorem to help us. Notice our c in this case is going to be called d. So maybe I can change this to a squared plus b squared is equal to d squared. So I'll just use a different variable. All right, so let's figure out how to get our a. We'll call this length a. Well, notice this distance from here to here is just the distance between the 2 x values. Well, this one's x2, this coordinate. This one's x1. So the difference must be x1 minus x2, or we could go x2 minus x1 as long as we put it in absolute value. So I'll go ahead and put it in absolute value. x2 minus x1 would be that length. Similar, here's the point y2. Here's the point y1. Our b side is just going to be the difference between the 2, or just y2 minus y1. And again, I'll use absolute value because I know this has to be a positive distance there. Okay, so if this is a, x1 minus, or x2 minus x1, and this is b, I have the formula a, so x1, a squared, okay, plus b squared equals c squared, but in this case we use d. Okay. Now notice, I can get rid of the absolute values since I'm squaring. Squaring something is always going to make it positive. So this can become x2 minus x1 squared plus y2 minus y1 squared is equal to d squared. Now if I just want to solve for d, I can certainly take the square root of both sides. Okay, and I'm left with d over here is equal to the square root of x2 minus x1 squared plus y2. And there is the distance formula. So that formula you definitely need to memorize, but I'm going to go ahead and write it again. Okay. Try to derive it. It's not too difficult to derive. Just remember you have to use the Pythagorean theorem. So let's go ahead and read this again. Theorem, the distance formula. The distance, we'll say d, okay, for distance, between points P1 and P2. That's what this notation means. Distance between P1 and P2 is, remember, the difference in the x-coordinate squared plus the difference in the y-coordinate squared, and we'll take the square root of the whole thing. So let's go ahead and do this little example. Find the distance between these 2 points. Okay. You can go ahead and plot it, give yourself a visual, but we don't need to. I'm just going to denote this point as x1, y1. I'll denote this point as x2, y2. So the distance between these 2 points, okay, let's remind ourselves what it is. It's the difference in the x-coordinates squared plus the difference in the y-coordinates squared. So we'll take the difference in the x-coordinates. It doesn't matter which way we go. I can go -5 minus 3, or I can go 3 minus -5, and I'll go ahead and do that. 3 minus a -5 squared plus -2 minus a -1 squared. Let's just simplify. 3 minus a -5, that becomes plus. So 3 plus 5 is 8. 2 minus a -1 becomes -2 plus 1, which is -1 squared. And then I'll just continue. Distance equals the square root of 8 squared is 64. 1 squared is 1. So D is equal to the square root of 65. Okay? And that's all there is to it. Okay? I did have another example, but if you can do one example, you can do every example. Just remember our distance formula, because we will use it every so often in this course.